weekend. I'm delighted as we start today's Gurukul 2.0 session, AWS for Beginners, a very interesting topic for all our participants here. Today, we have 4 speakers who will be sharing their knowledge with us. First, we have Mr. Kushal SL. Kushal SL, sir, is the founder and CEO of Sapientury, an edtech startup incubated at IIMB. With all the experience as director at his non-profit organization called the Vimana, at Sapientury, Kushal envisions to make outcome-driven engineering education easily accessible to all the engineering students at affordable rates. We welcome you, sir. Next, we
Thank you,
have.
Ritvik.
Thank you, sir. Next, we have Pujita MK. Pujita MK ma'am is a DevOps engineer at Sapientury. She is mainly working in cloud management and security. Her key skills being cloud computing and full stack web development. We welcome you, ma'am.
Thank you.
Next, we have Mr. Nagavishnu with us. Mr. Nagavishnu, sir, is the DevOps advisor at Sapientury. Being an incoming software engineer at Lam Research, he is experienced in cloud computing and infrastructure. We welcome you, sir.
Thank you, Ritvik.
We also have Dinesh with us today. Mr. Dinesh, sir, is the DevOps intern at Sapientury, who majorly works on AWS. He is skilled at cloud computing and ML. We welcome you, sir.
Thank you.
So without any further delay, I will hand it off to our speakers to start off with today's session.
Thank you, Ritvik. Just a quick thing. Whoever is the host, can you please enable polls in the panel? It is not enabled, so that I'll keep the poll questions ready. Thank you. So we'll begin, guys. Good afternoon, everyone. I hope everyone is having a great day, great weekend. How's your weekend going? I hope it's going great because mine is going great. I have full power-packed weekend scheduled on from today. So the webinar for today is AWS Fundamentals, where AWS for Beginners. I'll share my screen. I hope the screen is visible.
Yep.
Somebody can, thank you. I'll just present it. Is my whole screen visible?
Yes.
Okay, I'll just minimize this. Yeah. Yeah. So let's begin AWS for Beginners. Today we have with us 4 speakers, as Ritvik also mentioned. We have we have Kushal, CEO of Sapientury, Nagavishnu, DevOps advisor at Sapientury, myself, Pujita, DevOps engineer at Sapientury, and Dinesh Babu, our DevOps intern. So what are we learning today? It's very important to understand before the webinar begins as to what is our outcomes of the webinar, right? So what will we be looking at today? A quick intro on what is cloud. As this is for beginners, we've just divided it into 6 parts, namely introduction to cloud, getting started with AWS. We'll do a demo deployment. We have Kushal will talk about Sapientury and how are we using AWS at Sapientury. And more with AWS will be explained by Dinesh, who will be speaking about storage and containers. And at the end, Nagavishnu will be talking about relevance of the industry to cloud computing and how COVID has changed cloud as a whole, right? So let's begin introduction to cloud computing, right? So do you have this curiosity of how a website works? I open a website and voila, the sheet appears, right? It doesn't take me to a different website, right? If I open, okay, I hope all of you are vaccinated. You guys can give me a quick show of hands if you're vaccinated. And does it still take infinite time to register in the COVID app or to give so much time to get an OTP or something? Okay, I am vaccinated, so I'm not very sure of that. But yeah, so imagine if I want to get vaccinated, so I go to covin.gov.in, right? It'll take me to that website. It doesn't take me anywhere else. So how does that happen? Here is me, user who wants to open covin.gov.in. So I type in covin.gov.in, and the DNS server, that is some others, third-party server, will resolve that name to an IP address and give it back to me. To me, not exactly, to my browser. And the browser will establish a direct connection between the host and communicate with both of with the host forwarding all my requests, right? So there is a lot more things that happens in between SSL certificate, which protocol to be followed, all that. We don't look at it on a whole. This is what happens. I click on the website DNS server. DNS is domain name system. It has different it's a third-party server that is across different platforms. There are so many platforms that offer DNS services. So what does the DNS server do? Like, it will give me the IP address. It's like a huge logbook, you can imagine, and it will map each address to each IP address. And what gets logged? What does it take from me? It records who am I, not like my name and all, but yeah, my IP address, my location, and what am I browsing, what time am I browsing. So this is the overall view of a website. So when we see, I mentioned about host server. Where is the host server? What is the host server? Host server is the architecture of virtual system where application is constantly running, right? Your application is constantly running in order to fulfill the needs of your website. So where's the host located? The host can be located in multiple zones or single zone, right? So before it was so difficult, we had on-site servers that were giving us the applications, but today we see whole world can access the website from anywhere here to there, multi-regional, which means these hosts have become multi-regional and multi-continental, right? We can conclude that these hosts are everywhere, and they use cloud computing techniques to be readily available and accessible. Cloud computing, did I say cloud computing? So what exactly is cloud computing? We know what is computing, right? It's calculating. It's calculating, measuring, computing. We know it. So what is cloud computing on a whole, right? So what does the Google dictionary say? Cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. So cloud computing gives us you can access the data, you can store, you can manage, you can compute. Does that mean it's another system? Let's see how it started, right? How it started. In the initial days, they had huge companies, had big servers, room full of servers, and they had a lot of redundant servers that were lying around, and they thought it was waste. They decided as to rent it out. So when they started to rent it out, they usually rented out in small communities or in and around them, so that the website traffic was also increased. And later on, they thought, why not convert this into a service? And today, you can see Google, Amazon, IBM, and Microsoft offers you wide range of cloud. Every day, a new addition is added to it. Be it ML, IoT, analytics are offered every day, right? So all of them are working towards making our process and our lives easier. What does Steve Jobs say about cloud computing? I don't need a hard disk in my computer if I can get to the server faster. Carrying around these non-connected computers is fast time by comparison. This is what he says. Let's see. I mentioned about cloud computing having hard disks, right? So, which means we can access hard disks of somewhere else. So does that mean cloud computing is someone else's computer? Exactly, it's someone else's computer. What are the possibilities of me to have someone else's computer? The cloud computing, someone else's computer, you can think it in infinite possibilities computer, like it can have in so much storage, so much computational power. Example, you have a small laptop that does not give you enough computational power to do your ML or AI programs, right? So you can actually access someone else's computer from cloud and do those computations on the server itself. So next slide. So types of cloud computing. We have different types of cloud computing that is for your organization. Private is usually on-site and managed by you. Public is hosting it on third-party software such as AWS, GCP, etc. Hybrid is environment that uses public and private clouds. Let's see one by one. Public is, as I told, it's owned by third-party software. The main advantage here is it is infinite, right? Like you don't have to upfront tell this much I'm using, this much is what I want to use. It's like pay as you go pricing. So you can see there are multiple third-party software that are available, IBM, AWS, or GCP. So next one is private cloud. It is physically located in your company, or like you do it in your database. This is extremely for people who have confidential data, or somebody who need a really high data security, right? Like government organizations, or even sometimes some universities would want their data to be really confidential and private. So they use this kind of cloud computing model. So main disadvantage here is every time you are expanding or like scaling up, you have to manually add those resources to scale up. That is one disadvantage, but the advantage here is it's more flexible because you are controlling and doing all of it. So I think, yes, hybrid cloud. Next is hybrid cloud. This is the type of cloud computing that has on-premise as well as public cloud. This ensures edge locations. What are edge locations? Edge locations are those which are very far from a natural like place, right? Example, Antarctica. You have users in Antarctica. What do? You actually set up another server nearby to them in order for them to access the server or the service that you're providing. So you can have, for the rest of the world, you can have all of it on the cloud, and for just for the Antarctica, you can have the service provided there, right? So I think it provides more flexibility and it's more cost effective because it gives you that flexibility to have few things on the cloud and few things on premise. So let's have a quick poll here if the poll is ready. Okay, polling is ready. Kushal. I think I'll have to stop sharing for just a second. Okay, I kind of. Oh yeah, here. I'm so sorry, guys. Here's a quick poll for you guys. The time limit is 1 minute. Just make sure that you answer which is the most expensive cloud model according to you. Okay. Okay, that's awesome. Most of you know what is the answer. Awesome, great. I think most of you are answering and you guys know what is the correct answer. That's great. It's private cloud, exactly correct. So let's move on cloud computing models. So what are cloud computing models? Cloud computing models are 3 different models which satisfy unique set just for your business needs. It's infrastructure as a service, platform as a service, and software as a service. You guys can, oh yeah, I think the poll ended, right? That's true. So infrastructure as a service gives you hosting capabilities. Platform as a service helps you build and run the platform. And software as a service is something you access on the web with subscription model. and you consume that particular software as a service. So here is a better diagram to understand the same. So IaaS provides you a virtual hosting services on the internet by third-party softwares, be it AWS, be it GCP or Azure. And platform as a service allows you to build, run, and manage your platforms. Example, Heroku. Heroku gives you a wide range of products for you to just for you to run and manage without thinking about the infrastructure, right? Heroku Firebase allows you to host your websites without thinking of the backend, what instances you're using or what hardware you're using. So software as a service, everybody has used Google Drive. Every day we use Google Drive. Google Drive has become a part and parcel of our lives. So it's a software that is based on subscription and you can directly access on web. Even in fact, the Cisco WebEx is also a software as a service. So most of the softwares that we use are software as a service. So moving on. Getting started with AWS. We've covered the fundamentals of cloud computing now. We know that cloud computing is highly accessible, cost-effective, and infinitely scalable. So let's move on to AWS fundamentals now. AWS is one of the most popular cloud computing service that is used. It's extensive and elaborate to just explain it in one go. So there are over 175 plus services that are up and running on AWS. Every day they're sitting in their AWS offices and thinking, how can they make our lives easier and add a new feature in the platform or AWS. Here we'll be covering, you can see on the slide that it's on demand, easily available and pay as you go pricing. You have different varieties like storage, compute, and IoT, security, and analytics. You can even do a lot of ML-based applications on AWS. I think there's currently a competition or something going on DeepRacer about ML. So there are a lot of endless possibilities in AWS. You cannot imagine what level you can go on AWS. So in this we'll be mostly talking about EC2, load balancer, storage, and some additional features that Dinesh will be covering. So I'll just be covering EC2 and ELB as we go forward, and we'll have a demo session at the end. So what is an EC2 instance, right? So EC2 stands for Elastic Compute Cloud. It gives you compute capacity. It helps you quickly create servers whenever is necessary. But what exactly is an instance? An instance is like somebody else's computer. It's an entire computer, but not like computer that has a monitor, CPU. No, it's a virtual system that you can access through your command prompt. Like later on in the demo, I'll show how independently it runs as a system on its own. So let's take an example of coffee shop. So there are different employees in coffee shop, be it cashier, be it cooks, be it waiters, servers. Like that, we have different types of instances, memory and compute optimized for having higher RAM, and storage optimized for read and write access. If you have to specifically limit one instance to read and write, you use storage optimized. If you're computing something, then you use memory optimized. So auto scaling is when you have more number of customers in the coffee shop. What do? You hire more people, more employees just to serve those customers, right? So that is what auto scaling group does. It hires new instances just for you so that you can have more traffic onto your website. You can have like desired number, minimum and maximum. Desired number will be like the one that kind of tries to maintain, that is the amount that it tries to maintain and have it all the time. And minimum is the number of instances that should be minimum to the group, and maximum is how much do you want to scale up before stopping. So let's take an example, right? A coffee shop. We were just discussing coffee shop. So when there are number of customers and you have more number of employees, you've set up 2 counters also. But when there are number of people, this girl already has another customer standing here. So all of these 4, if they walk here, her life will be difficult, which means the instance will be loaded. So that's not what we want, right? When this guy is standing freely, we want these people to be distributed across this person and this person. That's what you do in a mall also, right? When you buy stuff, when you come back, you see which queue has the less number of people, and you go there. You even count the number of cart items, and then you go in that queue. That is exactly what this girl is doing. She says, how many orders do they have? How many people can I send? Where can I send whom? That is what this person will be analyzing. This is exactly what load balancer will do. The load balancer will analyze how many instances are has high traffic, which instance is free, which instance can I send more data, send more customers to. So load balancers does not have to specifically limit themselves to instances. As you can see here, she can be load balancing between even cooks also. She can tell which cook takes which order. So similarly, load balancer does not have to limit itself to the instances. It can be managing containers or IP addresses, anything for that matter, right? So it's secure, it's highly available and elastic, because we've already attached it to scalable auto-scaling group. It is also scalable. So that's a lot of talking, guys. I hope you guys have understood what an EC2 is and how EC2 works, what is an ELB, how an ELB works. So let's take up a demo deployment on AWS console, and let's familiarize with the AWS console and understand how to do a deployment on an EC2 instance. So we'll be deploying Prestashop from AWS Marketplace. Oh, hold on. Too many words. So what is AWS Marketplace? AWS Marketplace is a place where you have all of the softwares, all of the machine images, what we can term it as machine images, will be stored just for you, waiting for you to deploy them on an instance or on a container. You have container images. Dinesh will be talking more on what is containers, how to use them, but you can have container solutions, you can have instance solutions. There are multiple softwares that are ready for you to deploy. There are like even Amazon Linux images, or even an Nginx image that you can readily deploy and start mapping it out on your application, right? So what is Prestashop? Prestashop is an open source Bitnami package that is an e-commerce website. It's an open source website that you can access, application that you can run readily. Oh, wait, open source? Okay, yeah, open source. We see as people kind of shy out from open source, right? Like open source, though, I can build my own. Why should I use open source? As CS engineers, we all feel that. But one thing we have to remember in a production environment is starting from beginning does not mean starting from the bottom. You do not have to start from scratch every time you want to build a product or you want to build a service. Open source obviously is not the whole thing. You can't make your entire application on open source, definitely. But you can have like a skeleton wherein you can keep building and improving your own software on that skeleton. So let's look at what exactly is open source. Open source, there are so many open source softwares. Open source softwares are just that released under license or copyrights that you can actually study or change or like use them for your service and all that. So we never realized that there are so many open source applications. The open source word is so much taboo that we don't understand that open source is such a huge stream that where we are actually drinking from it every single day. Python is open source. Linux is open source. Every day we use Python and Linux. We wake up to Linux system coding in Python. So I think that's one thing we don't realize. Git is open source, and a lot of other applications that are offered, like some popular applications include Drupal and NOP Commerce. All of that are open source softwares that you can easily deploy, and you can kickstart your application or in a production environment with these softwares. So let's look at the demo now. So how are we going to begin, right? There are so many things in AWS. So we'll first go to Marketplace. As I told you, we'll be deploying from Marketplace. This is how AWS Marketplace looks like. We are installing Presta. So I'll just search Presta. So here it shows Presta, I'm going to take something that is certified by Bitnami, because Bitnami offers a lot of softwares that are readily available and are certified by it and has a wide range of documentation. I'll continue to subscribe. I'll go to configuration. So before, if I can click here, go to configuration. But if I do here, you guys won't be familiarized with the AWS console. So let's just go to an AWS console and see how it looks. So this is an AWS. This is how AWS console looks like when you sign in, and various aspects are here. So many things. Some of the familiar words: instance and auto scaling group, load balancers. These are familiar. We have already learned them. So auto scaling group, you can actually add instances and come back and scale them up for auto scaling group, or you can go to auto scaling group, create your own auto scaling group, and then put it on load balancer. Before putting it on a load balancer, as I just mentioned, load balancers can balance load on various types. So the types can include instances, containers, IP addresses, anything. So I have to create a target group for a specific load balancer to access and manage, rather than just having an instance auto scaling group. So I create an auto scaling group, I create a target group, and then move on to load balancer. I hope that kind of made sense. So let's look at the deployment now. You can actually see this is the how it looks. Here you can actually directly search for services. You can type in and it will come marketplace. It will give the most apt solution. So, or I can come here, I can search what I'm looking for here and then access it too, right? So here subscriptions. I go to marketplace subscriptions. This is how marketplace inside my console looks like. So I've already subscribed to the various things. This is what I have. So I'll put manage. I can launch new instance here. I'll click on launch new instance. It already has it pre-configured. Okay. Just make sure the region is fine for you when you're doing. So here you actually configure what type of instance do you need. When you click, it takes the default one, whatever is necessary for that particular software, or you can even change. You can have additional resources on it, or you can have memory. Here refers to RAM, and CPUs refers to the computational, how many virtual CPUs will be provisioned for it to access and continue. So let me configure instance details. So here I can actually go and configure auto scaling group and continue on the auto scaling group. Here I'm not going to do that. I'll just keep the number of instances one. I'll add the storage. You can actually add a new volume here, EBS, or you can actually add another volume, EBS. Dinesh is going to speak more on storage as to what is EBS and all that. This tags actually is like, you can group your instances together, whatever you want. You can group them. You can say these are the instances that I'll be grouping together. I can apply a particular health check. I can apply a particular feature onto it, or just group them and keep them together whenever you have a particular thing. So I'm not going to do that. So next, security groups. What are security groups? So these security groups are a set of rules that will be applied to an instance when you have them configured, right? So when you when you tell the port ranges, these are the ports that will be opened to that particular instance. If you do not specify it here, the instance won't work. A lot of times, a lot of people do this. Even in my initial days, I have also done it. We forget to specify a port here and keep checking what happened. The instance will be showing healthy, the instance is running, but you don't know what happened. You can't connect to it. So make sure all of your ports that are required are mentioned specifically here. I'll click on review and launch. It says all of my configurations that I've set, and then I launch. Okay, key pair. When I have to connect to an instance, I told you it's you can access the instance on your computer from your shell. So for that particular thing, I have to have a certificate, right? I am this person. I am certified to access this instance. The same thing is here. I can choose an existing key pair or create a new key pair. Please remember to have that particular key pair with you when you're doing this. If you do not have that key pair, you cannot connect to the instance. I acknowledge that I have access. This will actually take 5 to 7 minutes to get configured. So what I'm going to do, because demo is not our main objective here, I already have an instance that is running on the same software. I'm going to show that instance. How do you connect to instance? How do you manage it? So when I click on this is my instance that I've already pre-configured on the same. This shows me public IPv4 DNS. This is my instance address that I'll be accessing in order to get the instance application. This will actually ask the privacy settings because it's a new application without HTTPS and everything. So this is how it looks like. This is an open source. This is the power of open source, guys. Like I've done nothing. This is just the new deployment that is there. You can actually go into this and access on a new tab. Okay. Yeah. On a new tab, you can go to administration and you have the administration window open. So, like I told you, you can access this instance as someone else's computer. So how do I do that? I connect here. You can go to your, you can copy this command and go to your command prompt. Go to the place where you have the key pair, the same folder. You don't have to, it doesn't have to be the same, like the file exactly. In the folder, you open this, you type this particular command that is already here. I'm just copy pasting that command. Because it's a Bitnami instance, I have to put Bitnami, else it will just be root or admin based on the application. Some of them have root, some of them have admin. So when I give, it will ask me for fingerprint. Yes. Ask me for fingerprinting and I type yes, and it will be added and it will open. So this is a shell legit. This is a Linux instance. You can actually see all of the Linux people who have already worked with Linux. You guys know all of these things are available in a Linux system also. So you can use this instance as a Linux instance by having multiple configuration, multiple programs that can be running. You can have code from GitHub, run it here and see what can be done in additional changes, or you can set up your own web server by having your code from GitHub. You can do all of it. It's just a small instance. So I was telling you, like, it's a Bitnami instance. What does Bitnami offer, right? Bitnami application, it has wide range of so many applications ready for deployment, and it's more certified and easier to deploy. So there's a wide range of applications, and all of them have extensive documentation ready for you to understand and configure any applications you want, be it e-commerce or edtech or even CRM tools, if you are familiar with that, or even, one of them is, I think, there's something called Discord. It is a video chatting app, something like that. So you can have all of your bare bones for your application and start using them today. This is the power of having an instance on AWS. This is the power of having an open source software to build on your application. I think we can take a quick Q&A if you guys have any questions on AWS Console. If you guys want to explore anything else on AWS Console, if you guys want me to show you something on AWS Console, you guys can specify. Oh, you can't see. Oh, you couldn't see the shell, is it? Okay, I'm so sorry. I think I'll share. I'll stop sharing and share my full screen. I think now it's visible, right? you can see in the shell that I've accessed. And okay, great. Sorry for that. I'm really sorry. You have to have, I think I can explain it. I'll just run through it once more. Just make sure you have this particular key pair which you downloaded while making an instance. I'm actually copying the command from the instance itself. Instantly, when I put connect, it actually gives me the command. This is the same command I've used here. I think it asks for fingerprint and it adds me, and then I have the whole range of I have an access to complete EC2 instance, and you can see a lot of these folders are present in any Linux machine. For you guys, like whoever has Linux, you can actually see all of these are present in any Linux machine, and you just have to take care that some of the instances will be on CentOS based, which means you have to use a different type of command, and some of the instances will be Ubuntu or Debian based. Then you have to use sudo apt-get. Here in CentOS, you have to use yum install. That is one thing you have to figure out which instance type is that and use the command. Apart from that, this is just a Linux instance where you can bring your code from GitHub and have it running across the instance and have it running on the cloud. Do you guys have any questions? You guys want to explore something on cloud? You can. I hope the chat box is accessible for them. At least like give me a thumbs up if everything is clear and you guys are happy about what I presented. I'm still on. Oh, yeah, thank you. So I think I'll go back to PPT now. I'll just close the not required tabs. Okay, so this completes my part of presentation. Thank you so much. Now our Kushal, CEO of Sapientury, will be continuing the presentation on Sapientury and AWS. Thank you, guys.
Okay, thank you, Pujita. That was, fantastic. First of all, good afternoon, everybody. Thanks for having me here today. Very privileged to be talking to all the IEEE participants. So I think, Pujita touched upon multiple points. Some might be new if you haven't touched AWS at all, right? But if we go back and see what just happened is if you want to buy a laptop today, you're constrained so much by 16 GB memory, 8 GB memory, and 256 GB SSD. If you want to pay anything more, then you have to pay more than a lakh. If you want to add graphic card, then you have to think about it. If you want a metal body just because you want to have it very fancy, then you have to think a lot about it. So we have limited funds on a one-time investment that we do, because once you buy the laptop, it's there with you all the time. But what if you want to use or build an application that needs more computing power, more storage? So essentially that's what Pujita said. How do we use just for a while somebody else's computer that can either give you more computing access or more storage or more graphics capability or much more other features? So as student, if you want to run MATLAB, machine learning, or whatsoever, and your computer is only limited by 2 GB, not ready to invest in a new laptop, AWS is where you have to go. So if you have any more questions, the whole team will be so much more happy to help you out with the questions. Now let me jump to explaining about how we as a startup, edtech startup, Sapientury, make use of AWS. Or maybe even before I get there, let me give you some background, something more like a context of what is happening with the engineering education in India. So Pujita, next slide, please. Giving you a revelation, guys, to everybody. India is the largest producer of what again? Engineering graduates, with more than 3 million engineering graduates going out of college every single year. Yet the National Employability Report of 2019 reported that 80% of them, by and large, are not fit for engineering level jobs. They are underqualified, and they are put into jobs which they are considered overqualified. They're not fit for engineering level jobs put together. So it begs the question if engineering education is really a professional degree, or is it just a de facto mere certificate of participation? Just like if you came to this webinar and we said we are going to give a certificate for participation, it feels like we are going to college for 4 years and getting a certificate of participation with very less skills than what you can get in 4 whole years, right? So why does this happen? Why is it so pathetic? See, Indian engineering institutions have been failing to provide students, all of you, with any opportunities that promote experiential learning, hands-on learning, or steady and continuous skill development. You learn something in first year, has nothing to do with what you learn in third year. So there is no continuity, right? It's not progressive learning. So there is a big problem there. And more of all, there is no industry coherence at all. Nobody speaks about how to work with AWS, even though you happen to have a elective on cloud computing, you just read the theory. So it's not industry coherent or industry relevant. Upon this, we have engineering labs in many of our universities that are filled with obsolete equipment, working on something that the industry needed 20 years ago, and some of them are probably broken. Some of them, the teachers come and hold your hand and say you have to weld it like that. You are not allowed to do this. So that's how engineering labs work, with 20 fixed experiments, fixed results, and you pass only if you get that result, rather than experimenting to check whether the hypothesis is true or false. To add on to that, we have outdated syllabus, not just the labs, even the books are outdated, and there is not enough diversity. It's so rigid, right? You have maximum 1 to 2 electives per semester. So how can you say I'm going to learn something beyond than what every other person in my class is studying, when the industry is having varied and diverse needs? So there is no way to cater to that. And moreover, no emphasis on multidisciplinary projects. You are a computer science engineer, you have to do computer science project. You're working on IoT, then build IoT. Do not involve more on mechatronics, do not work more on mechanical. This is how most of the subjects and the projects are aligned. So no emphasis on the need for multidisciplinary thinking at all. I hope you're all agreeing. If you do, then put a thumbs up, thumbs up, or whatever reaction you feel like putting up. If you're resonating with whatever I'm speaking, face the same problem out there. Okay. Yeah. A couple of them are doing it. Awesome. Yeah, maybe we can also add on to that because of this lockdown and all the things going digital, everything online, the universities have a false sense of understanding what digital is. They took the classroom and put it on Google Meet. Whether the internet works, whether the students are learning or not, whether the students are switching a tab and watching Netflix, the administration is not very bothered about it. I'm happy at least we're trying to keep it more engaging. So maybe you guys can put up more reactions and keep it a low profile. That's totally okay. So we want to keep this event at least engaging. Okay, thanks, Dheeraj. So putting it all, it's not just about complaining. How does Sapientury make it any better at all than universities, right? So next slide. Uh, so we said to ourselves that we as engineers are going to re-engineer a new and parallel track of engineering education alongside with the existing academics track. So in this, we are introducing agile learning by Sapientury by adopting an instructional design framework filled with agile philosophy, the popular agile project management methodology adopted by industries. We have alternate phases of learning and doing. So we prefer learn as you go rather than learn from books and forget it and try to recall and then try to put it over an application. So learn as you go. And how do we do it? We iteratively reinforce the engineering mindset via these 3 tracks that you can see on the screen. Let me dive a little more deeper in each of those. Watch and learn track is where we host interactive micro courses. These are bite-sized, not those 1-hour NPTEL courses that you find. These are bite-sized, having 5 to 10 minutes of video content, and each micro course not comprising more than 100 minutes of learning. made very personalized to what the industry needs are, which is co-created by a wide network of industry professionals. We got people coming from Philips, Airbus, Amazon, name it, and we are trying to bring them all on board. So you watch and learn the best content, well recorded, self-paced learning. And then we got Build and Learn track, where we offer project-based courses that are coupled with online kits like AWS that you're seeing, and offline kits like Arduino, Raspberry Pi that gets shipped directly to your home or your college so that you can watch online and build offline. Because when you build things, when you put things together, the kind of learning that you have, the learning curve goes like this. So that's what Build and Learn automatically does to you. So we co-create this learning content with project platforms like Raspberry Pi, Arduino, MATLAB, Autodesk, ANSYS across multiple branches of engineering. Yeah, and when you have sufficient learning credits in Watch and Learn and Build and Learn, well, you're all ready to get into internships, right? Remote learner-centric remote internships. These internships are not the ones which says, go get me coffee or go post that on LinkedIn, not that kind of internships, but more learner-centric, where you apply what you have learned in Watch and Learn and Build and Learn in that startup or SME. Why startup? Because startups, they have a tough time finding talent, and GPA alone is not helping them find the right fit of employees or interns. So they are more than happy to work with us and get trained and tailor talent to work with them. And you working in startup, you'll learn both about how you apply your knowledge into startup and learn a lot about multiple nuances that exist in a startup and a production environment. So putting it all together, friends, watch and learn, build and learn, and work and learn. Agile learning by Sapientury. Let me make it more interesting for you. Yeah, keep it here, Pujita. So what we can do is, we can consider this particular session to be a watch and learn session, right? You're on a webinar and we are watching and learning. You're listening. Of course, this is instructor led rather than self-paced training, but that's all okay. I know this is all watch and build, watch and learn is what's happening here. What we can offer next is post to this webinar, we are going to be sending out to all the interested and dedicated candidates some quick tasks that you can go on AWS and work on, right? That whatever you're learning, you're going to be applying. So we're going to call that Build and Learn track. And if you do happen to perform those tasks well, um, we can offer internships directly at Sapientury. And I'll also tell you what kind of internships and why you want to work. But we are just giving you a quick demonstration of how we are trying to apply agile learning in almost every walk that we do here at Sapientury. So amazing news probably for the ones who are very interested in AWS and want to extend your learning. You're in Watch and Learn. Post to this webinar, we're going to give some tasks for building and learning, and probably will give you a little more guidance while you're working on the task. Post to that, you will be offered internship opportunities directly to work with us. So what kind of internships? Well, maybe you can move to next slide now, Pujita. Okay, great. So we have a learning management system to digitize, personalize, and automate learning processes. We have already built a rudimentary learning management system, and this is what it looks like, where we have dynamic and interactive learning content. The video pauses, it asks you some questions, and keeps you motivated, keeps you engaged throughout the whole course. We have multiple micro courses broken down into modules, broken down into sections, broken down into units, so you can stay more accountable. And then you get these beautiful analytics, which will align you with the best learning practices. It will help you understand what time of the day are you watching these videos the most. How can you improve learning? Well, if social media can track all the data and keep you on their platform, we help you by tracking your learning data and giving the analytics so that you can keep a track of yourself. So that's what we have today, a learning management system to take care of all your learning processes. So the people who come in will be working on improving this learning management system, which is already there, but we want to make it more useful, more more learner centric, more user centric, highly scalable. The big terms that Pujita was speaking. So that's what we want to make, and that requires more AWS engineers who are good in. So Pujita, if you go to the next slide. What's the problem? Is my audio better?
I think there's some issue with the mic, sir.
Oh, is it better now?
No, sir, there's a lot of static.
Just a second. Is it still there?
No, sir, there's a lot of disturbance.
Now it's fine.
Now it's fine?
Yes, yes.
My microphone.
Yes, sir, it's better now.
Not sure why that happened. Okay, getting back. Thanks, Ritvik, for notifying me about it. Yeah, coming back here, we have two teams, Devops and Sysops, where DevOps engineers and Sysops engineers together are continuously working on planning, coding, building, testing, releasing applications feature by feature on every 50-day time period. So what does this mean? Instead of working for 10 plus months on developing an application, then pushing into a market once in a year, like how most of the traditional softwares used to work like 5 years ago, we do feature by feature, planning, coding, building, testing, and releasing, so that we can stay in par with the market needs and demands. So we keep learning what the users need. We go back, we update the requirements, and then we build it and we keep deploying. So as quickly as possible, what we say, as agile as possible. And it's not just about building, right? We need to see that it cater to the needs of the user in the production environment. So we keep deploying and operating and monitoring how the application is working on the servers and how the servers are taking the application to the users and how are they finding the experience altogether. So DevOps engineers work primarily on building the application, putting it on multiple environments, development, test, and production, and they take care of continuous development, testing, integration, and deployment. While the Sysops engineers team, they support the production infrastructure on AWS platform by monitoring the development and deployment environments and troubleshooting all the production issues and ensuring in coordination with DevOps team that the application is smoothly running 24/7/365. So that's what we do here as AWS engineers, as two teams, DevOps engineers and Sysops engineers. So if you do get to, watch the whole webinar, well, work on those tasks that we're going to give. So you might have an opportunity to work along with us. And of course, you might want to know what's our startup progress like, how have we been working. So Pujita, if you can take us to the next slide. Okay, excellent. I didn't see that animation coming. Okay. Anyhow, coming back here, well, we started off our startup in early Jan. We completed our market research. Whatever the platform that you saw was built in the month of Jan, Feb, and partially in the March. And okay, and in the months of March and April, within 6 weeks, we released into the market with a learning program that we call DICA. Do you know Arduino? For teaching Arduino for beginners, we had 150
Sir, issues come up again.
Oh, I'm so sorry about that. Noise again. Let me read.
No, it's fine now, sir.
Fine
it
now?
just got fixed on its own, yeah.
Okay. Okay, please keep me notified. I'm sorry about that.
Sure, sir, sure.
Okay.
No worries, sir.
Yeah, coming back here. So we have had 150 paid student customers over the month of over 6 weeks during March, April, and May period. And we completed market validation with an extensive and exclusive student feedback successful conduct of program. We said, okay, 150 customers, we're going to go back and check how can we make better. We worked in the month of May to revamp our platform and the program, and happy to also excited and happy to announce that the sales for DICA 2.0 is starting right from today. We have started sales. So it's another happy news for Sapientury. And speaking about, there is a quote that goes, show me your friends and I'll show you your future, because you're an average of 5 people that you grow up with. And, if you're working with Sapientury, well, we have a winning team here, right from the start of Sapientury. We got recognized as top 50 student-led startups of India, inspiring student-led startups of India, chosen from 17,000 plus universities across the country. And we are a DPIIT recognized startup currently incubated at NSRCL IIM Bangalore from, again, 9,000 applicants. And in the month of May, last month, we also won the Global Social Impact Award by Thai Pitch Fest. And I think a week ago, we got selected as top 80 teams by Cisco and NASCOM Foundation. Again, the digital transformation leader who's going to be of a great partnership support for our company, where we are trying to digitize all the education happening. So putting it all together, like I said, we are going to be an amazing team who are building true engineers instead of just degree holders. So if you are excited about it, we are so happy to hug people who are winners and onboard more winners onto the team. So that's about Sapientury, and that's about how we are using AWS here, and how you guys can come, learn whatever we are learning in this webinar and come execute this all together. So I think I have 5 more minutes. If you have any questions, happy to answer about the startup. Else, we'll go away from this promotion and learn more about AWS. So quick questions, any? No negative marks for wrong answers or wrong questions. And I'm not going to eat anybody. Yeah. If you find it very tough to unmute yourself, or if that option is not there, you can put it up in the chat box. Somebody asked, Shashank, is the internship for beginners as well? Of course, Shashank, that's what we're speaking about. Everybody over here started as beginners. They were all students. Some are still students, right? So you're going to come in as a fresher, and you're going to be going through a very power-packed learning track where you're learning and applying at the same time. So yes. So that's from Shashank. Do we have any more questions? Again, universities have built so many engineers who are finding it so tough to communicate. Sapientury got to do something about this. Okay, looks like that is all it is. Thanks for the time. Thanks to IEEE. Over to you, Pujita. Maybe the next slide. I think Dinesh Babu is going to take over. Okay, over to you, Dinesh. Thank you.
Thank you, Kushal.
Before that, I'll just stop my screen sharing and share it again. I have to get the polls ready for the next one. So,
sure. Meanwhile, hello everybody. I'm Dinesh, and I have been interning with Sapientury for a little while now. And before we go any further, I want one of you to tell me what an EC2 instance is, because we had a very engaging session with Kushal as to what Sapientury does, and you might or might not have forgotten what EC2 and ELB are. So if one of you can quickly put in the chat window as to what an EC2 instance is, or your basic understanding of what it is, we can go from there. Anybody? On the chat window. Have we been listening? Yes. Shashank says Elastic Compute Cloud. That is the full form of EC2. What is it? Just a small, just 5 words, 6 words. Just what did you understand is EC2? Are we ready, by the way, Pujita?
Yes. Yes.
All right, great. Anyway, if anyone is willing to answer that, please do so simultaneously, as and when I am explaining more on AWS. Now, moving on, the first thing we'll be looking at is storage. Apart from computing, you need place to store information, right? Your 500 GB or 1 TB on your personal computer is not enough, right? So storage. And this shouldn't be confused with memory, right? RAM and ROM. We're talking about ROM here. Now, there's too many storage options in AWS. So let's look at the first one, right? S3. What is S3? S3 is simple storage service. It is an object storage, right? As in you're storing it in one blob, one giant, beautiful blob. It is cheaper because you're not cutting it up or anything, right? And that's the problem. The problem is that when you need to make changes, you need to re-upload the whole blob, right? Let's take an example. If you need to edit a huge movie, you can't make localized changes. Every time you make a change, you need to re-upload the whole movie, and movies are big, right? I mean, you'll know if you try to sit through Radhe, it's a big movie. Now, how do we remedy that? We remedy that using EBS, or elastic block storage. So here your memory is stored in small blocks, right? And this is used if you need to make quick and frequent changes to your storage. So now, if you need to change something, just that block changes. Now, when we looked at EC2 instances, even they have their own little storage, and we call that instance storage. But the problem with instance storage is that once the instance stops running, the memory is forfeited, right? The memory vanishes. So if I launch an instance, it is running, and I stop it, the memory associated with that instance is gone. And that's not what we want, because we should be able to launch and relaunch an instance and still have memory sitting there. And this is why we need ABS, right? You link your EBS, your elastic block storage, to your EC2 instance. So even if you start and stop your instance 100 times, the memory exists. Moving on, what is EFS? EFS is elastic file storage. And like the name suggests, it is a full-fledged Linux file system. So if your requirements, say whichever company you're working with or whatever, needs you to store data in the form of a file system, it needs you to organize data in the form of a file system, use Linux commands on the data that is there, you can use EFS, right? So that is where we are as of right now. S3, EBS, and EFS. Moving on to database storage options. We all know what relational databases are, right? Amazon RDS is a relational database. So if you need to store your data in the form of tables, right, that are related to each other, you can use RDS. In a relational database, right, each row in the table is a record and has a unique ID, so that you need to identify that record. And each column is an attribute of that record. So suppose if I have a table that says customer of the coffee shop that Pujita mentioned, right? So if there is a customer table and you're storing customers, your key would be customer ID, a number that you assign to a customer, and your attributes, each column would be, say, your customer name, what coffee they like, and their address and their phone number and whatnot, right? And this is how you use a relational database. And there is RDS for MySQL, PostgreSQL, MariaDB, and any other enterprise level SQL software that you can find. So what does that mean? What does this mean? This means easy migration. So suppose you want to shift your database from your local system to AWS, you can do that easily. Now, lastly, we come to DynamoDB. DynamoDB is a NoSQL database. So if your data need not fit the tight constraints of a table, it need not have your keys and your columns and just a set number of attributes, and your tables need not be related to each other, you can use a NoSQL database. NoSQL database uses something called key value pairing. So there is a key and there is a value, but the value or the types of values that you can store is flexible. So that is why you use NoSQL databases. Now, here are a few more miscellaneous features, right? You can't possibly cover AWS in an hour or 2 hours or 6 hours even. There are full-fledged courses that will that pertain to each and every single feature of AWS. And all we want out of this webinar is that you feel motivated to learn more about AWS, right? So, security. AWS security groups are associated with EC2 instances. And then now we know what EC2 instances are, right? Your own personal computing power, your own little computer up there. Now, security groups are associated with EC2 instances, and they provide security at the protocol level and the port access level. If you notice the demo, she said, Pujita said we have to specify the ports, right? While specifying your security groups. So that is to ensure that any information passing through that port is regulated by the security group. So how this works is that it works just like a firewall, right? It has its own set of rules, and it will just filter traffic that is coming into and out of an EC2 instance. So suppose a certain user is authorized to send traffic to an EC2 instance, that packet will pass through. And if you notice that a certain user is malicious, that one won't pass through, right? The thing is, it will validate anyone who is going in, but it is state aware. So it knows, it remembers who goes in or what packet goes in, right? So it need not validate it coming out. So that is security group. Now, risk and disaster management. Again, during the demo, you saw something called a region. What is a region? An AWS region is a separate geographical area that AWS uses to house its infrastructure. Say Mumbai is a region or Tokyo is a region. How do you choose your region, right? You can sit here and choose Sao Paulo in Brazil as your region, but you need to choose a region that is closer to you and closer to your target customer, because these regions are distributed across the world, right? And the closer the region is to you, the better, because you can reduce your network latency. You need to take into account the speed of light here, right? Because I know the speed of light is insane, but still the time it takes for information to travel from a data center in Brazil to a data center in Mumbai is a sizable delay. So you need to take that into account. So that is what a region is. Now, what is an availability zone? An availability zone is a local building block, right? And it makes up an AWS region. And by building block, I mean building, full-fledged building. So each region has multiple availability zones. Now you might think, if I have a region, why do I need to have multiple buildings in that same region? If I want a region in Mumbai, why do I need to specify why is there a need for multiple availability zones in Mumbai? You see, this is for a property called resilience. Each region has multiple AZs because each AZ has backups of your data, and you need to design your infrastructure to have backups of those data in multiple availability zones. We'll take an example. Suppose a region R, say Mumbai, has 3 availability zones, X, Y, and Z, and they are at least tens of miles from each other, right? So say availability zone X crashes quite literally because of an earthquake or something, right? Now, what would happen if there weren't any availability zone? That's it. Your data there, gone. You are not operational anymore. But because you have multiple availability zones, the redundant data in availability zones Y and Z ensure that you stay operational, right? So that is what I mean by risk and disaster management. And that AWS does for you beautifully, because if you have your own private server sitting in your computer, one small crash and you're not operational anymore, right? Last but not the least, analytics. CloudWatch and monitoring. Amazon CloudWatch is a monitoring and observability service, and it is built for people like us, DevOps engineers, developers, and IT managers. CloudWatch, it provides you with data and actionable insights to monitor your applications in real time so that you can respond to performance changes and you can optimize resource utilization. So what do I mean by optimizing resource utilization? You see, at a certain point, there's high traffic, right? And even your minimum number of EC2 instances is not needed, right? So you're redundantly, as in you are uselessly running an extra number of EC2 instances or something along those lines. At the end of the day, you need to optimize your costs, and that is what is going to keep you afloat as a company. And analytics and CloudWatch in particular will help you do that, right? So CloudWatch collects monitoring and operational data in terms of logs. Every single thing that is done on the cloud is collected as a log, and it can be used for auditing purposes as well. So you can use CloudWatch to detect anomalous behavior in your environments. You can set alarms. You can visualize your logs in terms of graphs and pie charts, and you can take automated actions. You can actually ask the system to do a certain thing if it encounters a certain problem, right? So that is what CloudWatch does for you. Now, let's move to the next topic. Containers and Kubernetes. Now,
Dinesh,
next
before that, I think we can have the poll.
Oh yeah, poll on storage. Apologies.
Yeah.
Yeah, there's a quick poll
Guys,
on
you guys have
storage.
1 minute. Please answer the.
Yeah. So which one of these two is a bucket and why? I'll ask one of you why. Pujita, I can't see the results.
To answer. Oh yeah, 4 people have answered as of now. I'll let you know, like 1 minute, yeah. After 1 minute, I'll let you know how many people have answered.
Sure.
You guys have 20 more seconds. As of now, 6 people have answered as S3 and 7 people have answered as S3 and 3 people as EBS. Guys, the poll ends. Thank you.
Seems like most of you are getting it right.
Yes. 10 people have got it right and 3 people have answered EBS.
Yeah, like I said, S3 is used to store your big blobs. So you just throw it in a bucket. It is literally called an S3 bucket. So that is why an S3 storage is also called a bucket. Moving on. Containers and K8s. We'll go to the next slide. Yeah, we will look at Dockers and K8s, right? Now, Dockers. We will look at a process called containerizing. Next slide. Yeah, what is containerization? Like it mentions there, it solves the problem of, but it worked in my system, right? A lot of the times, that's the only problem I face personally. I'm given a software and a friend says, hey, it works in my system, it's great. And he gives it to me and there's a billion dependencies I need to install and nothing's done. And I spend half an hour to an hour sitting and installing those dependencies and debugging those problems rather than actually doing productive work. Containerization solves that problem. Everything an application needs to run, its binaries, its libraries, its configuration files, and its dependencies is encapsulated and isolated in that container, right? The container itself is abstracted away from the host OS. So it doesn't interact with the rest of the things in that OS, rest of the applications in that OS, right? Now, a better way to explain it would be, it's like a lightweight virtual machine. You know how virtual machines work, right? Run it on a hypervisor, and then it is its own operating system. This is just like that, except that it's lightweight, because virtual machines are huge. If you've tried installing one, you would know how much time it takes, right? So because it is a lightweight virtual machine, it can run anywhere. A containerized application can be run on bare metal, on VMs, and on the cloud, and you don't need to refactor it according to the environment. Like spend half an hour and install a different set of dependencies and whatnot, right? Now, what is a Docker container image? A Docker container image is a standalone executable package of software. It has everything inside it. All you need to do, run it, right? Now, what are the benefits of containerization? Your first benefit is a consistent environment. Let's take an example. All right, you're at home. Everything's great, right? It's lovely. It's beautiful. You need a pen or your reading glasses or your earphones, but it's not there. It always happens to me. My mom keeps changing things around and it is chaos. Mothers, right? Now, I spend a lot of time fixing that instead of doing actual work, right? I walk around the house yelling at my mom, trying to figure out where I left things, and it's chaos. Containers give the developers the ability to create a predictable environment, right? And this environment is isolated from all other applications. It's like a little bubble. It's like a nuclear bunker where your mom's not allowed, and like your radioactive debris and everything, mainly moms. It's like an isolated system. So containers can include your software dependencies needed by the application, specific versions of programming language runtimes, and other software libraries. So look at it from the developer's perspective, all right? All of this is guaranteed to be consistent no matter where you deploy the application. And that is heavenly to think about, right? And all of this translates to productivity. Like I said, as a developer, you will spend less time debugging and diagnosing differences in environments and more time shipping new functionality for your users. As Sapientury, we will work more on giving you more features, helping India's engineers learn better than trivial things like environment, right? Isn't that great? And it also means fewer bugs because I, as a developer, I can make an assumption. So based on my dev and test environment, I can make an assumption that wherever this goes, production environment, that will have the same set of dependencies pre-installed right there. So I don't need to, I can make safe assumptions as to what works, right? Moving on. The second benefit is the run anywhere benefit. Imagine you can carry this nuclear bunker. Wouldn't that be great? You have this little bubble around you and nothing disturbs you. I'd love to do that. I'd love that any day. I'm a little bit of an introvert, so it's great. Now, containers are able to run virtually anywhere, and this makes development and deployment easy, right? Linux, Windows, Mac, VM, bare metal, on a developer's machine, data center, or even the cloud, anywhere, and it runs. And also, so this Docker image I spoke about, right? That format is very popular. Developers around the world use it. So this also means portability because if everyone is using the same kind of format, then there are more things built for that format, right? And when there is that level of homogeneity in things that are done, then it means there's more support for a person that is building it, right? Isolation. So containers, what they do is they virtualize CPU memory, storage, and network resources at the OS level. So it gives me as a developer a sandboxed view. I will know how my application specifically interacts with the OS, irrespective of the other things that are going on around it, because my application is sandboxed. Moving on. Now we are done with containers. Okay, containers are great. They're lovely. Oh, which brings us to our next poll. Pujita, if you can put it up. Yeah. So I've spoken a lot about containers. Isn't that great? Don't you think it's great? It's a fairly obvious answer, isn't it?
Almost all of them have answered yes, like almost all of them. So, yeah.
Sounds good. We will get to that later on in the presentation. Anyway, so moving on. Now, containers are great. They're lovely. They are a wonderful way to bundle and run your application. But in a production environment, you need to manage these containers, right? You need to ensure that there is no downtime when these containers are running. So for example, if a container goes down, another container needs to start. Wouldn't it be easier if this behavior was handled automatically by a system? And that is exactly how Kubernetes comes to the rescue. Kubernetes is an orchestration tool. It is nothing but grouping and clustering your Linux containers, and it enables scaling and easy management. So it provides you with a framework, right, to run distributed systems. And it does a lot of things, a few of which we'll be looking at right now. The first thing is service discovery and load balancing. So Kubernetes, it can expose a container to the outside world using the DNS name or the IP address. And if the traffic to the container is high, Kubernetes is able to load balance and distribute the network traffic so that this deployment is stable. This means your ELB is not required in this particular context if you're using containerized applications and Kubernetes, right? The next one is automated rollouts and rollbacks, right? So what you can do is you can say, hey, I'm here. This is my current state. I will give you a desired state, right? For my containers. And it can automatically change the state of your system and of your containers from the actual state to the desired state at a particular rate, right? For example, you can automate Kubernetes to create new containers for deployment, remove certain existing containers, and adopt all of the resources that these removed containers used to the new containers. And all of this can be automated. This is why you use Kubernetes, right? So it's like a game. I am at checkpoint A, I need to get to checkpoint B, and voila, it's all done. Automatic bin packing. You know what the bin packing problem is, right? You have a bunch of bins or boxes, and you need to fill those with materials. These materials need to be filled in a way such that the bins are filled optimally and a minimum number of bits are used, right? How do I put it? It's like playing Tetris. You guys have played Tetris, right? Those little blocks trying to fit in. You can look at it that way, right? And that's exactly what Kubernetes does. Once you provide it with a cluster of nodes that it can use to run containerized tasks, and you tell K8s how much CPU and memory that each container needs, it will automatically fit your containers into nodes such that it will use your resources in the best way possible. And the last feature I want to talk about is self-healing. So let's say some containers fail, and they fail all the time, right? Kubernetes restarts the containers that fail. It replaces containers, and it kills containers that don't respond to your health check. And it doesn't advertise them to clients unless they're ready to serve. So basically, if some container is not working, the clients don't see it, right? So that means better reviews for your site. Now, next slide. Everyone uses containers because everyone needs a stable environment to run things, right? I can't run around and make this presentation. I need to sit, I need to have an environment where I don't have people walking into the room, and that is exactly when I can do the job. So everyone needs a stable environment to run things, from software development to fintech to healthcare. All companies, 10,000 plus companies use containers, and more than half of those are orchestrated. Look at some of the examples there. Pinterest, Shopify, Spotify, Twitter, Udemy, everybody, right? And for obvious reasons, you need to control your containers. And half of your containers are orchestrated, right? So 10,000 companies are using, there are 700 million containers, close to 400 million containers are orchestrated. And 70% of those orchestrated containers are orchestrated by K8s, right? So that brings us to the end of my portion that I have to present to you. And I hope this workshop was a seed for you to want to learn more about AWS, containers, Kubernetes, and of course, cloud computing. Thank you.
That was awesome, Dinesh. So guys, now that our fantastic teammates have conveyed the knowledge that you have come here to grasp, let's see, with having learned and gained all this knowledge, what do you do with that knowledge? You have to apply it somewhere, right? You have to see where it has scope to apply it, right? So how it is relevant to your current world. So that is really important, where you have to go and apply the knowledge that you have gained. Okay, the subject is awesome, the tech is awesome, but you need to know where should I apply. It should be accepted with relevance. So, this pandemic hit and everyone had to stay at home to protect ourselves. But still, you are not allowed to go to grocery shops and buy groceries initially. What did the grocers do? They said, sit at home, we'll deliver it to you at your doorsteps. What You were not allowed to go to restaurants and buy food. What did Zomato do? Sit at your home, we'll deliver the food at your own place and you can enjoy the food, right? So all the tech companies were running. What did all the software companies do? What did all the software engineers do? They were going to the companies and working together and making products happen, building softwares, right? But then once they had to sit at home, they can't be like, boss, I'm at home. I don't have the infrastructure. I can't work in my laptop. The boss will be like, बहाना देना है तो मेरे company से बाहर जाओ, right? But still, they had to keep their company running. How did this all happen? How did they make it possible? It's by collaboration. How was that collaboration possible? It's with the shared workspace. It's by the possibility of cloud. It's what the cloud gave us, right? With the advent of new and powerful technology, there also rises the expectations of computational resources. Guys, take it from me, today, if you go to any tech savvy person, I am for sure you will hear the humming of word data. They hunt for data, 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 data everywhere. What does this data even mean in its raw form? Not much, right? It needs to be processed. The phrase data needs to be processed sounds vague. So what processes do we do on the data? It obviously depends on the application. So let's understand by naming a few. IoT, as you all know, is Internet of Things, which is accumulation of sensors and remote computation, right? And big data, which is the field that analyzes huge amounts of data to produce meaningful and vital insights to support various services. Artificial intelligence is booming right now. It is the field where the machine takes in huge amounts of observational and algorithmic data and generate its own intelligence, right? For various purposes, various applications. The possibilities with artificial intelligence is limitless. So let's, for instance, consider the example of artificial intelligence. Okay, that is a booming topic right now. You might all relate with it. You might all be inspired to take that stream, right? So let's consider that example for a minute. One amazing thing we can observe in our own nature's creation is the ability of a baby to understand its home language. A baby can understand its first words only when it is 9 months old, not earlier. By this time, it would have heard around 5 million words in total, which would be analyzed by hundreds of billions of brain neurons in that tiny little baby. So if nature's creation requires so much of computational data and so much of computational power and data, just imagine how much a human's creation would require to achieve even a basic intelligence, right? You can relate it. You can relate the scale of it. So the present generation, who is always curious, is continuously willing to dive deeper into tech and innovate something, to create something new. So as we discussed, this demands for a huge amount of resources. It is practically impossible for each individual to own all the resources he requires. How great would it be if it was possible for him to use all that he wants to use for just as long as he wants to use and pay only for so much that he wants to use? Well, that's enabled by the concept of cloud computing by AWS, for example. We have innovators and creators all over the world working towards achieving a greater purpose that's very much bigger than their own individual selves. Collaboration is the key, guys. Everyone that is aligned towards the same purpose can achieve greater heights of work together constructively. As Elon Musk says, if you can't beat them, join them. That's an emphasis on constructive collaboration, right? To make this collaboration possible across the globe, it's really a boon to have shared workspace, resources, and one entity of truth to work on. This is enabled by cloud computing. If I have to mention the scope of cloud computing in industry employment, there are 30,000 plus jobs listed in LinkedIn alone for cloud engineers. You can go and check it on your own. Big giants such as AWS, GCP, Microsoft, Wipro, TCS, Cisco, not can't name them all. There are many huge companies that in each and every technical domain that are in hunt of skilled cloud engineers. How do you get skilled? Understanding the right things in the right form and applying it at the right places with the support of right people, right? So this is about the scope and the practical relevance of all that you learned today. Hope you had a great introduction to AWS with practical hands-on experience by a fantastic SME and have understood the importance and scope of cloud engineering too. Right? Now with this, I'll be ending. Open to questions and answers, guys. Shoot them.
Thank you all so much for such an amazing presentation. We will now be taking questions from our participants. Please do drop your questions in the chat box, or you can use the raise hand option if you want to ask the question yourself.
I think there's already one question in the chat box long ago when I was taking. What do we define an instance of a particular software or web app? I just want to know the boundaries to which it is capable. What do you exactly mean by define here, Shubham? Can you just explain your question? Shubham, are you still here with us? Yes, I was talking about having different softwares. So do you want to know what is the level that you can have definition on cloud? What kind of software you can have on the cloud, or is it that is your question? Okay. It's you can have multiple softwares on cloud, Shubham. You can even have your own web server that you have running on your personal computer on cloud. You can actually set up if suppose you have a Django application or a Node application on your system, you can actually go ahead and serve it up in the cloud and have it running for 24/7. Or even you can use a lot of machine images that are available in the marketplace to set up your Nginx environment in order to constantly run your Django server. There are so many, as Dinesh was talking about Dockers. You can even use Docker containers inside your AWS EC2 instance and have it running even on Dockers. Does that answer your question?
If I can add to it,
Yes, sure.
So if you want to use containers in Kubernetes, Amazon has its own Elastic Container Service and Elastic Kubernetes Service. So all you need to do, you can have any application or anything you want to use cloud computing for. All you need to do is look at Amazon's documentation and read up a little bit about it, and the possibilities of cloud computing is endless, right? Yeah.
Okay, probably, just to add one more point over there, to make sure that Shubham got the concept of instance, image, and the concept of software right. So an image is like a blueprint, an application that you have stored at one place. Instances are copies of that blueprint, of that application that you take and you run on multiple virtual machines. You want to customize, you customize based on your needs. So I'll give you an example here. So we build one image and we say this image is for the learning management system application owned by Sapientury. Okay, so we take that application, run it as an instance, and we say this particular software or this particular instance will be more modified for this one particular program that we have called DICA 2.0. Do you know or do you know 2.0? It's one program. So I took the copy of the skeleton of the blueprint that I have created and I made changes in the front end and the back end such that it's good for DICA program. I can do the same by taking that image, putting it as another instance and make it possible that in partnership with IEEE, we conduct another probably 10-day course on AWS. So that's another instance. So blueprints, we take them as instance and we modify to create instance and we run them on virtual machines based on the required needs. Yeah, that's all from me. So if we have more questions, you can shoot them up. I'm kind of curious how people don't have a lot of questions. Either we did a fantastic job. Okay, Shashank has something. Team, anybody want to take this question? AWS versus GCP versus Azure?
Yeah. So Dinesh gave you various information about how AWS provides its services, right? So geographical region where the server infrastructure is present. That is different with respect to AWS, Microsoft Azure, and GCP. The resilience, the security options, and the way it is served to you, and the way you are able to connect to it, and the support that is given is differs from AWS to Azure to GCP. The analytics that you can monitor with respect to each instances varies across all the three providers. So all the three of them provides you the cloud services or the service of instance, but the features, but the way it is accessed and the support it gives and the reliability, security, resilience differs from one service provider to the other. If you want to add anything, team.
I would like to add on to it. It's very important to understand one particular thing first in order to understand all of them. You can actually start off by any of those. If you have a personal choice, you can start off with any of those, and basic configurations will remain the same. Like the basic functionalities will remain the same. We spoke about load balancer. We spoke about having a scaling group. We spoke about having containers and Kubernetes. All of them will remain. All of those will also be a feature in, maybe they'll be named differently, but they'll still be present on GCP, Azure also, or even IBM for that case. So I think that answers your question completely.
Yeah. Thanks, Pujita and Naga. Summing it all, they're almost the same in how the features are given to you. The environments are a little different, and we have worked both on GCP and AWS, not very hands-on on Azure and IBM Cloud. GCP has also been great. Our previous deployment was on GCP. Now we are on AWS. And one thing I could say is AWS will raise its flag a little more higher than the other ones because of its existence in the market. for a longer time, and how fast they evolve their features, and how many people have adopted AWS, has a biggest market share. Can't think of the number immediately. If some team member wants to bring it up, that's great again. But yeah, they have the biggest market share across the world. So, the big companies, Facebook uses AWS, and yeah, many other big companies. I believe Spotify uses AWS, Udemy uses AWS. Yeah, a couple of them to name. So yeah, if you want to start, anything is good. But if you want to scale it super big and want to have more resilience, AWS would be good. But the best part of all is, like I said, you're not investing one time and you have to have it forever. You pay as you go. You want to run it only for 2 hours, get charged only for 2 hours, then AWS would be good. They're charging per hour. Sometimes GCP cycle would be for per day, or sometimes 1 hour. So if you're going more than 1 hour, then you're costed for second hour also. But AWS makes it a little friendly for your pocket by saying we charge based on every minute. So that's one thing as a student may be important if you have a money crunch or budget crunch. Okay, any more questions? So we got a couple of minutes left, maybe 4 more minutes before we hand it over back to IEEE, Ritvik. Oh yeah, Dinesh, you got a question?
So Kubernetes can use external storage as well. So what Kubernetes essentially is that it is it uses it automates container deployment and maintenance of containers. Now your containers still have a little bit of a connection to the outside world, to the underlying services. So even if Kubernetes is managing your containers can use your external storage, right? So built-in storage systems are not required for container orchestration. So yeah, if that answers your question.
I think I would like to add on further on it.
Yeah, sure.
Kubernetes, as Dinesh told, Kubernetes is just managing your containers, and it's not an independent application. You are linking Kubernetes to your cloud application, be it in-house or public. You are linking it through different Kubernetes that is offered by AWS as well as GCP. AWS offers two kinds of Kubernetes, ECS and EKS, and GCP offers its own Kubernetes engine where you can configure, and it uses memory from the cloud, and Kubernetes does not have a built-in memory. I mean storage. Yeah.
Does that answer your question? Okay, great.
Okay, cool. So thanks, Dinesh and Pujita. Summing it up, Kubernetes is an orchestration process, and there are multiple K8s engine, just like how Pujita mentioned now. And every engine is trying to become an all-in-one platform. Previously, we saw Dockers is only for containerization. Docker is a container, but they are also trying to build their environment where they can have more integrations. So there is some diversity in what different engines can do. So probably you can consider that as extended learning. But to exactly answer your question, there is no inbuilt storage services within Kubernetes. So I think we have time for one last question if somebody wants to shoot it up. Maybe Pujita can jump to the last slide on this presentation. We can touch upon when not to do containerization, because they also need to know, though containerization comes with a lot of advantages, it's not an easy process, right? So yeah, probably Dinesh, you can add a few cents on this.
Yeah. This is why we had that poll, because all I did was give you a lot of advantages of containers that you were blinded to the certain constraints that they have. The first thing is that security is tedious. You see, when you have a container, you have a lot of things in that container. So you are trusting all of the dependencies and the applications that are running parallelly with the application that you've built, that all of the sensitive information contained in your application is just out there in the container, right? And you are trusting every dependency there. So even if one dependency is malicious, your container fails, which is why, if you remember, I said containers fail all the time, because they do. Another thing is that orchestration tools have upfront costs. So in order for you to orchestrate how your containers are deployed, and all of the things, and maintain them, and look at all of the things that are happening around them, you need to purchase tools. There are open source tools available, but you're going to have to, more often than not, purchase orchestration tools as well, and they have upfront costs that you need to shell out, right? So those are your disadvantages of containers. So if you don't have a lot of money to shell out up front, or if you are worried about security, please do not use containers.
Okay, thanks, Dinesh, for adding some points there. Well, if you want to get rid of these disadvantages, you can work at Sapientury. It's going to have all of that sponsored. Going back, if you want to work as individual alone, maybe the previous slide, Pujita. So if you want to start off just as a student, you also have AWS Educate, where you can go out and create an account, put in your credit card details. But even before using it up, credit card, I think you'll get a $25 for using the cloud, and then $75 worth of learning materials. Pujita, correct me if I got the numbers wrong. But yeah, this is how we can start off immediately, people.
The numbers are not entirely wrong, but on AWS Educate also, you have a lot of free resources that can be used, and that will just let you have a demo of whatever they will be providing it to you. Like, you have to put in exact values and figure out a demo around the console yourself.
Oh yeah, thanks, Pujita. That gets me to another point. There is also a free tier on AWS that you can be using. You can go figure that out. You can be running it on a F1 micro VM, and you can deploy it for free over there. That's one other way to get started with. Okay, I think that was all from Sapientury as a knowledge partner, with IEEE as the outreach partner. Back to IEEE. Ritvik, over to you. Thanks for the opportunity.
Thank you so much, sir. Thank you all, Kushal sir, Pujita ma'am, Nagavishnu sir, and Dinesh sir, for such an intuitive, interactive, and knowledgeable session. Thank you so much for investing your time from your busy schedule to help us learn so much. I'm sure all the participants here watched and learned something useful, which will help them in their careers. You're not only just helping by this session, but I'm also sure the task under Build and Learn and the follow-up internship availability at Sapientury through Work and Learn will also be a lot of help for us here. Thank you so much for doing such an amazing session. We would like to thank all the speakers with a small token of gratitude. Thank you all the speakers. To all the participants, I would like to tell that there'll be a feedback form sent to your mail. Do fill that up and let us know how you like the session. And so that would be it. Thank you so much again. Thank you so much. Thank you all the participants for attending. Thank you speakers for spending your time with us and helping us learn something new. Thank you.
Thanks a lot, Ritvik. You managed it well and helped to proceed smoothly. So it was a great
Thank you so
experience.
much, sir.
Thank you, Rashad.
Yeah, thank you so much for having us. Thank you.
Thank you. Thank you.
Thank
Thank you
you.
so much.
Thank you, guys.
All right, thank you very much, IEEE team. So probably in the feedback form, you can include the link that our members are going to give probably by end of night, which could be learning resources, come a quick task that students can go through. And if they do perform it well, then we can schedule technical interviews right from Monday.
Definitely, sir.
So
Sure.
signing off here, the whole Sapientury team, you did a great job again. Thank you for coordinating so well from the beginning to end, and so much great gratitude towards IEEE too. Thank you, everyone. Have a good evening. Bye bye.
Thank you. Thank you so much. Bye bye.